Offload test of the meter. To test energy meters, AMT transducers and master rooms can be used. On Start page, the AMT Transducer and Meter Room software is opened. This room is comprised of the two main windows of Test View and Transducer Characteristic. In Test View window, it is possible to perform a shot test for various quantities and compare the results with the meter characteristic. To begin the test, after completing the information in Device in General Test Object window, double-click on Transducer option. On Transducer Properties page, it is possible to view a set of functions. To test the meter, two functions of watt-hour and watt-hour are used. Here, watt-hour is selected. By selecting Injection option, in Input section, it is possible to perform the offload test of the meter by injection from the device. The other option is Read from Binary, which is used to perform an unload test of the meter. By selecting this option, it is necessary to enter the values into inputs of the device using the clamps and interface cables. In Output section, it is possible to specify the type of the output received from the meter. To test transducers and their corresponding outputs by selecting current or voltage options, it is possible to take the output current and voltage values to the inputs 9 and 10 for measurement. To test the meter, if only the output values are being displayed on the screen, open loop option can be used. Here, pulse option is used so that using the light sensor which comes with the device, the number of the output pulses of the meter is recorded. In CT start point connection section, the connection related to the current transformers are specified. Since the active power flows from the bus bar toward the line option is selected. Selecting toward line is in accordance with the injection of the active power from the device to the equipment. If toward bus bar is selected, 180 degrees are added to the angle of the current. In full-scale error reference section, it is possible to specify the error recording reference, which can be selected from a range of 0 to the maximum or negative to the positive maximum. If the characteristic is asymmetrical, the range is from 0 to maximum, while if the characteristic is symmetrical, it is possible to select both options for error measurement. As for error measurement, suppose that for a transducer with a characteristic with the maximum input of 1 ampere and output of 33 milliamperes, for a 0.5 ampere current, the output of the transducer equals 16 milliamperes. In such a case, the error percentage is calculated as follows. This means that ideally, for a 480 milliamperes input, the output equals 16 milliamperes. Therefore, the absolute error value equals 20 milliamperes and the error percentage equals -4%. This method is used for cases where full-scale error reference is set at 0 to positive maximum. It should be selected from among 0 to positive maximum and minus maximum to positive maximum. For the previous example, if the characteristic was symmetrical and minus maximum to positive maximum was selected, the following relation is used for full-scale error calculation. In tolerance section, it is possible to enter the error value as an absolute or relative value. The default values are 1 millipulse and 0.25%. Finally, comparison is made between these two values and the larger value is selected as the allowed error value. In number of phases section, it is possible to specify whether the meter is single phase or three-phase. The test characteristic is specified in characteristic definition section. Since the meter characteristic is linear option is selected as the characteristic type and it is uneditable. To specify the energy import and export values, it is possible to check the symmetrical option so that there is a symmetrical characteristic in both sides available. The minimum value, knee points, and saturation range fields are disabled for meter test, but in maximum value section, it is possible to enter the amount of power and the number of pulses received in exchange for that amount of power. Usually, the meter factor, or C/R, is entered in this section. For example, the factor for a EDMI MK6E meter equals 5000 watt-hour per pulse. Note that by using primary and secondary options at the top of the screen, it is possible possible to enter the values as primary or secondary in accordance with the meter type, which needs to be done considering the CT and PT conversion ratios. Relative and absolute options are used for displaying the absolute or relative amount of the values. After entering the values, OK is selected to continue with the test. After completing the information in Transducer Properties section, the hardware configuration settings need to be examined. By opening this window, you can see that the current and voltage outputs are set by default. In Binary Analog Input tab, you see the binary number 8 is selected to record the pulses of the meter by default. However, it is possible for the user to use any other binary if necessary. By clicking on OK, the applied changes are saved. To perform a test, a point on the characteristic must be selected, which can be done using two methods. 1. Entering the values in the Fields of Test Point section, which means entering the related parameters including watt-hour value, number of pulses, test performance time, and frequency. Then by selecting Add, this point is added to the test table. 2. Holding down the Control key and then clicking on the meter characteristic curve. On Test View page, by clicking on Advanced View, a page opens where it is possible to enter the voltage, current, and their angle, as well as the cosine phi to be injected by the device. Moreover, in Waveform section, it is possible to add phase shift and DC offset to the harmonic-specific signals. After specifying these values, apparent, active, and reactive powers are separately calculated for every phase and displayed in the box at the bottom of this section. If necessary, it is possible to make changes from this section as well. After adding the intended points, the test can begin, and after the time is specified in accordance with the pulses and watt-hour elapsed, the results are displayed. In performing this test, some points must be considered. If a test point is specified in watt-hour mode, 0 is entered as the value for reactive power and by default. And to change this, first the current angle needs to be changed from I angle field. The time entered in time field by the user changes in accordance with the characteristic curve of the meter. This changes in a way that the number of pulses change to integer. Being out of range for the option in this test depends on the required time for performing the test. Since the maximum injection time of the device is 4,000 seconds, if a test point needs more time for the test, that point becomes out of range. To change the state of this point, more voltage or current can be entered in Advanced View section. If a too large value is entered in watt-hour field, this value is recorded as NA, and by selecting Add, this point becomes out of range.